This is a somewhat quick, somewhat slow explanation of the many things you need to know about quadratic functions, most of which you should already know before taking pre-calculus or calculus. The first thing you need to know are the two ways that you can write quadratic functions. The first one is called the standard form. Standard form has its own uses, and the second type is called general form, which most often we're more used to seeing. So standard form looks like y equals a x minus h squared plus k. Or in the future, we'll be using one that looks like x minus h squared equals 4p y minus k. So notice the difference between the two. This one, though, we will not be worried about right now at all. General form is the one that I would assume you're more used to and some of you might like more, and that's your typical y equals ax squared plus bx plus c, which you should know a lot about when it comes to quadratic formula and the discriminant. The vertex is one of the most important parts of a quadratic function because it's actually also the maximum or the minimum of the function depending on whether that parabola faces up or down. It also is one of the ways to develop the entire parabola. It's halfway between both sides of that parabola. So the vertex is very important. In standard form, the way we find the vertex is it's actually just h, comma k, which means the max or the min depending on which way it's facing. If it's an upward facing parabola, that's your min. If it's a downward facing parabola, then it's your max. The only tricky part about talking about the vertex being h comma k is that you'll notice that the notation is x minus h, where h is part of your vertex. If this were x plus 3 squared, the 3 is not your h, negative 3 is your h, because the standard form is x minus h. So the plus 3 has to be turned into x minus negative 3, which makes negative 3 your h value. Once you have your vertex, meaning your maximum or your minimum, it's easier to draw the parabola from that. If you want just a rough sketch, if you have your a value, well, if your a value is positive, that means you have an upward facing parabola, and if your a value is negative, you have a downward facing parabola. So if you can figure out that your vertex is 3, 7, and your a value is negative 2, a rough sketch of this graph would have 3, 7 as your vertex, and you know it has to go that way. Now that's very, very rough. The best way to graph that more accurately would involve either making an XY table or to use more specific information that we'll come up with later. When using general form, the a value still means the same thing. If a is positive, your parabola opens upwards, and if a is negative, your parabola opens downward. But finding the vertex, and therefore the maximum and minimum, is a little bit trickier, but not crazy. Both of them stem from back in Algebra 1 when we learned the axis of symmetry. Typically, when you first, even before talking about vertex and maximum and minimum, you talk about the axis of symmetry because there's a quick little formula for it. The axis of symmetry of any parabola, meaning this line that shoots down the middle, is always the vertical line, at least in y equals equations, x equals negative b divided by 2a. Well, so that's the x value of our axis of symmetry, which means that if I'm looking for the vertex, it has to lie where the x value is negative b over 2a. The harder part, not crazy, but harder part, is in order to find the y value, you have to plug negative b over 2a into x in your original equation, ax squared plus bx plus c. So the final product for your vertex would look something like that, which obviously if you do it all out or at the beginning will just be a number and much easier to work with. But notationally, this is definitely more difficult to look at than the notation for standard form. You may already prefer one of the forms to the other form when talking about quadratic functions, so what you really need to know is how to convert from one to the other. Standard to general is the easiest one because when you take y equals ax minus h squared plus k and you want to rewrite it in ax squared plus bx plus c, all you have to do is distribute and then combine like terms. General to standard is the more difficult one because if I already have ax squared plus bx plus c and I want to be able to rewrite it so that I have a parenthesis squared, this x minus h squared, you may or may not recognize that what we need in order to be able to do that is everybody's favorite, completing the square. Completing the square is not super easy. Maybe you're good at it, maybe you're not, maybe you don't even remember it. That's something that definitely needs to be discussed, but does not need to be discussed right now. So for now, we're only going to look at writing equations from standard to general rather than general to standard, and we'll continue to talk about the advantages to both. Despite your preference for which form you like to use to write the quadratic in, finding x and y intercepts are both the same exact process. To find a y-intercept, you plug 0 in for x, and automatically once you simplify, you get y. Very easy. To find x-intercepts, you plug 0 in for y, and this one's only slightly trickier because you actually have to solve for x, meaning you might have to add something to both sides, divide on both sides, take a square root of both sides, or in many scenarios, you'll either have to factor or use the quadratic formula, which you should all know and remember. But, in case you don't,
x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Now here's a question for you to answer in your notebook or on your iPad and bring me the answer to class. Why, in the notes and on the slide, did I put a parenthesis s after x-intercept but not y-intercept? So why can I say x-intercepts, but I can only say y-intercept? At this point, you should probably pause and write that down. Just so you can see how all of this comes together, I'm going to do one example of each kind, the standard form and the general form, and show you all the things that we learned. So first, if I find the vertex, y-intercept, and x-intercepts of this equation, what I'm going to do for vertex, well, that's fairly easy. I know that the vertex is just h comma k, so that'll take me all of 2 seconds, 4 comma negative 4. There's your h, there's your k, including the negative sign. Then to find y-intercept, that's the other easy one. I'm just going to plug in 0, so I get y equals 0 minus 4 squared minus 4. So that's 16 minus 4, which is 12. So my y-intercept is 0 comma 12 because the x value is 0. X-intercept, set the equation equal to 0, meaning plug 0 in for y. I get x minus 4 squared minus 4. There are a couple ways you could do it. You could distribute first, but what I'm going to actually do is add 4 to both sides. Take a square root of both sides so that I get plus or minus 2 equals x minus 4. Do not forget your plus or minus. And then I'm going to take the positive 2 and add 4 to it to get one x value of 6. And I'm going to take the negative 2 and add 4 to it so that I get the other x value is positive 2. And that's all because I have to add 4 to both sides here, but there are 2 things I'm supposed to be adding 4 to. So my x-intercepts turn out to be 6 comma 0 and also 2 comma 0. Part B asks us to graph the function. In order to graph any function, you can make an XY table, but you can also use for the quadratic the information we discovered before. For example, we know the vertex now, we know the y-intercepts, and we know the x-intercepts. So if I want to plot the vertex at approximately 4, -4, and the y-intercept is at 0, 12, the x-intercepts are at 6, 0, and 2, 0, and when I draw this final parabola, it looks roughly like that. Obviously, it's a very rough sketch because there is no grid on here. If you use graph paper, it works out better, but that's a rough approximation of that graph in under 30 seconds. If I wasn't talking, it'd be even faster. Finally, rewriting the quadratic in its other form, as we said before, we're just going to use the distributive property, so this gives me x squared minus 8x plus 16 minus 4, which gives me a final general form answer of x squared minus 8x plus 12. And then you can do the same things with this that we said we could do with general form. Just like standard form, we can find the vertex, we can find x and y intercepts, and we can graph it. What you should do at this point is pause this video and try this example. Find all parts A, B, and C. For part B, sketching the graph, it can be a very, very rough sketch, and actually this is going to be one of the only times where I don't mind if you do not use graph paper. Feel free to use graph paper, but you do not have to. I just want it to be approximate. And don't forget that this parabola, because it's a -2, is going to be facing down. Otherwise, the entire thing will be wrong. Bring your solution to class and we'll go over the answer there. Hopefully you did the last problem. I am now going to complete the other type, which is where we have general form, and we're going to answer the same questions, but starting in this direction. So first off, I'm going to use the x equals -b over 2a to find my axis of symmetry, which is, well, the a value is 1, so this is -2. Axis of symmetry, again, remember, means that I can find the vertex, which is going to be -2, comma, whatever I get when I plug in -2 up in the original. So that's -2 squared, which is 4. -2 times 4 is -8, minus 6. 4 minus 8 is -4, minus 6 is -10. So there's my vertex. To find x and y intercepts, we do the same thing as before, and y-intercept is even easier in this one because when I plug in 0 for those two x's, I'm left with 0, -6. The x-intercept for this involves me doing 0 equals x squared plus 4x minus 6. And at this point, I have to look at this and decide, are there factors of 6 that add up or subtract to give me 4? And if not, that means I have to use the quadratic formula. It does appear for this one that I'm going to need the quadratic formula. So as it was stated before, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'll plug in all my variables, which when all done out gives me -2 plus or minus root 10. So that if I want to start trying to graph this, I'd have to plot -2 plus or minus root 10. So -2 plus root 10, well, you should know that root 10 is going to be a little bit bigger than 3. So -2 plus something a little bit bigger than 3 is going to be roughly somewhere around 1-ish. So that's here. -2 minus root 10 is going to be -2 minus around 3-ish, which is going to give me around -5. So I plot that. So now I have my two x-intercepts. I know my vertex was 0, comma, oops, not 0, -2, comma, -10. So that's around here. And when I graph this, it looks roughly like this quadratic. If you look back at our y-intercept, you can make sure that that's the correct spot, approximately. But as always, this is completely approximate because I'm not drawing it on graph paper. If I drew it on graph paper, it would look better, be more accurate, and I could plot the actual points. But for now, this is a good representation of my parabola. And for part C, as stated previously, we are not going to do this yet because it involves completing the square, but when we get to it, we can come back and check out this example. At this point, you have another example that you can try. This is the end of the video, so you do not have to pause it. Try to do parts A and B. If B gives you any trouble, you always have your calculator to look at, and do not do part C at this point in time unless you're really good at completing the square already. Once you finish, you have completed the not-so-brief lesson on quadratics.